Hello Science Alliance, welcome to our third plants lesson. Last week we looked at roots, we looked at how water gets into a plant. So this week we need to look at the stem, this bit. How does water, it's all very well water getting into the roots, isn't it? But how does water travel all the way up here? Plants are just amazing physicists and engineers. Like some trees are 116 metres tall. How does water get that high? We'll have a look. Right, so first of all, we have to do an activity. Have you got a penny? Hello, Ruben and Kai in London. All right, Pee-wee the guinea pig. Have you got a penny and a teaspoon? Hold the teaspoon by the, what's that bit called? Hold the teaspoon by the spoon, and we're going to use the handle. This is an activity, if you look up Science Activity Kids online, you find this activity really fast. I've never done it. It's about surface tension. You know, if you look at water, water looks like it's got a skin on it. This is an activity to sort of show that, and I was always like, everyone knows about surface tension. It's actually really cool, and it really relates to what we're doing. Hello, Lauren. So let's do it. Right, all you do is get a penny and put drops of water onto it, and just see what happens. Like, see how many drops of water you can fit on a penny. Let's go. The results, as they say, might surprise you. So yeah, someone doesn't have a penny, which, yeah, it's a common thing these days to not have any money in the house. I don't know what you use if you don't have a penny. I mean, actually, like my handle's got a bit of a lip on it. You could just do it with that. Some people yesterday were saying, like, I got 22 drops. You can count them if you like. Oh, I should know this as a physics teacher maybe. Are all drops the same size? I don't think they are. Wow, look at that. Oh. It's Walter. Sorry, Walter. Hello, Walter. It's easier. Hello, Tali, Mishka, Aoife, and someone else who's just gone off the screen. Oh, Noodle, Swift and Twinkle. Oh, for goodness sake. Stop making me do pet shout-outs. Come on, look at that. Can I do more? I can do more. It's quite beautiful, isn't it? So this is happening. Ah, lost it. So why does that happen? Why can you get that looking so good? It's because water particles are a little bit like magnets. They behave like magnets. So one end of them, one end of them is a bit attractive to another end of the other magnet. They're a bit like magnets, okay? They stick together. Water particles are a bit sticky. Now, as a physics teacher, it pains me to leave it there, but this is biology, so we are going to leave it there. We're going to look at some good words. So you can imagine water particles as being like tiny little magnets that arrange themselves so that the attractive ends are stuck together. If you want to know more, if you're desperate to know about what's happening to the atoms in the water particles, then ask me at the end and I'll tell you. Or if you're a patron, you look in your Snow magazine, learn about hydrogen bonds. But the word for the fact that water particles stick together is, you ready? It's a good one. Cohesion. Water particles are cohesive. You might have heard this word before. If you've ever planned to rob a bank, then someone might have said, we need a cohesive plan. We need a plan that is going to hold together, not fall apart. So cohesive is just a posh word for saying that water particles stick to water particles. Water sticks to water. That's what makes that film, that skin on top of your water. Water sticks to water. But if you dip your finger, 26 drops, Alex, 11 drops. Abby, yours might have been massive drops. Stick your finger in your water, and then have a look. You'll see that the droplet is hanging off your finger, so the droplets are sticking to each other, but they're also sticking to your finger, aren't they? So water not only sticks to itself, it also sticks to other things. Oh, thanks, Jenny, it's off the screen. Is that better? And there's another posh word for the fact that water sticks to other things. It's adhesive. Adhesive. Water sticking to other things. You've almost certainly heard that word before. Like when you were planning to rob the bank, someone might have said, we need to adhere to this plan. We need to stick to the plan. Water sticks to other stuff. You don't have to learn these words. You could very much, at this stage, just learn that water is sticky. It sticks to itself and it sticks to other things. But if you like long words, then you could learn cohesive and adhesive. Yeah, so what does that have to do with plant stems? Well, we'll make a little stem. We'll make a model stem. and we will find out. So if you've got an A4 piece of paper, just roll it up into a tube. Misha, well, it was drops from a teaspoon and it was a pound coin. Oh, okay. So give it a good roll. We're just essentially going to make a straw. If we'd done this lesson like 10 years ago, we would have used a plastic straw, but now probably you don't have plastic straws in your house. Yay, the world is getting a little bit better, isn't it? Slowly but surely. Here we go. Now, because water particles are adhesive, once you've made your little tube, if you like, make it as thin as possible. I'm going to make mine a little bit thinner than that. Because water particles are adhesive, once you've made your tube, you don't have to use sellotape. You could just put a little bit of water on it and that'll keep it in place. Nice, eh? It's a good activity, isn't it? I can feel that you're still putting pennies. 30 drops from Ethan. Ethan, that is a lot. All right, there we go. I'm going to put a little bit of water on my tube to adhere it. The water is adhering to the paper. Can we use metal straws? Oh, Emily, good question. Well, ideally not. I mean, if it's all you've got, then yeah, you could do. But paper is better. It's just a quick one, this. Okay, so what we have made, if you've done that, is a xylem. What, another good word. Basic, just a tube. The tube that is inside a plant that carries water. Xylem begins with a X. Someone pointed out yesterday, excellent Scrabble word. The xylem, there's different tubes inside the plant. We will look at some more in a couple of weeks. But the xylem is just the tube which is inside the stem, which carries water from the roots all the way up to the leaves. You can stick the paper if you want, Lindsay. I wouldn't bother. I'd just hold it. Or I've just put a bit of water on mine and it's nicely stuck. So the xylem is made of cells, just like all bits of the plant are made of cells. It's actually made of dead cells, which have got no ends, which is quite handy because that's how water travels up it, right? So the xylem kind of looks like that. So these are cells. But if it didn't come to cells, don't worry. It's just a tube, innit? Right. So if you've got a glass of water, stick your tube into your glass of water and see what happens. This is not a trick question. Xelent word. Oh, nice one. It's not a trick question. What are you going to observe if you stick water into paper? The paper's going to get wet, isn't it? How wet is it going to get? Is it going to get as wet as your finger? No, even wetter. This is a very good model because, look, let's put the water in the paper in the water. What happens is the paper gets wet, and the paper gets wet above the water, doesn't it? So you'll know intuitively, because you know how paper behaves, that water is going to slowly start to travel up your paper tube. Exactly, yeah, Mark. Saying, like, gravity, how does it go up? Well, one of the ways it goes up is just like this, because what is paper? Paper is just made of mashed up plants, isn't it? So there's plant fibres in this paper, and just like what happens in the xylem, in the plant tube, the water is sticking to the plant fibres and travelling up the paper. And also, because water is cohesive and sticks to itself, it's not just one water particle travelling up the paper. The water particles are sticking to each other like little magnets would do, and they're all travelling up the paper together. So that's one of the ways. Adhesion and cohesion would be like one of the GCSE answers for how water travels up a stem. But that's not the end of the story, is it? That is definitely not the end of the story. Water isn't going to get all the way up this tube just from dipping it in. What are we going to have to do? What are we going to have to do to this tube to make the water travel all the way up it? Don't do it, just say it. If you're watching this on YouTube later, it's just one word, you can shout it at me. If you're commenting, you can put it in the comments. What would we have to do to get water to travel all the way up this tube? It's nice, that's artsy, isn't it? Bit of lettuce in the foreground. It's just one word. Don't do it, don't do it. You gotta suck, haven't you? You would have to suck. So don't suck, because the people who made this paper weren't expecting you to do that. It's got like bleach in it. Mine's got some ink in it. Exactly. Thank you, Suze. Well done, Chrissy. Yeah, I'll do it a little bit just so that we know that it definitely happens, all right? But please don't do this. Or if you do it, just do it a tiny bit so that you can feel it starting to go up. Oh, disgusting. All right, yes, you have to suck. Now, what are you doing when you suck? Well done, Abby. Well, what you're actually doing is creating an area of low pressure. I finally made it about physics because that's my specialism. So what is air pressure? What is pressure? Well, pressure really, there's air all around you, okay? You can picture air particles as just being teeny tiny little balls wandering around, and they bump into stuff, okay? They've got energy, they move around, they bump into stuff, and when they bump into stuff, we call that air pressure. So you've got air bumping into you now all the time, you're feeling a lot of air pressure. If you give particles not very much space, then they bump into each other and other stuff more, and we would say that that's an area of high pressure. If they've got loads of space and they're free to move around, we would say that is an area of low pressure. So for example, take this balloon. At the moment, there's a hole in the balloon, so air can travel in, air can travel out. The air on the inside has got just as much space as the air on the outside, so the air pressure is the same on both sides of the balloon, just sort of normal air pressure. What happened? Emma got water in your mouth. Yeah, Aidan, I'm sorry, I shouldn't have told you to suck. I'm going to blow up the balloon. What's going to happen to the pressure? So what I've done is I've put more particles inside the balloon. And look, there's a higher pressure inside the balloon. The particles inside the balloon are bashing into the sides of the balloon a lot more. So much so that they've stretched it out. So we've got an area of high pressure inside the balloon, lots of particles with not very much space. And we've got normal pressure outside the balloon. What is going to happen when I let go of the balloon? It's not rocket science, is it? Is when I open up this hole again, is air going to go into the balloon? No, it's going to come out, isn't it? That is because last week in Roots we looked at diffusion, how like squash goes from an area where there's a lot of squash to where there's not a lot of squash. Air does the same thing. Air moves from areas of high pressure to areas of low pressure. You say it spreads out. Stuff moves from areas of high pressure to areas of low pressure. If you came to the show that we did on birds, you'll have seen me demoing this with a toilet roll. So if you blow over a toilet roll, something quite cool happens. If you blow like that, what you're doing is you're blowing air particles out of the way. So the air particles here have more space, right? So this area suddenly has low pressure and underneath has high pressure. So look what happens. It moves up. Who knew? Area of low pressure, area of high pressure, toilet roll moves to where there is low pressure. Right, it's quite fundamental that if you're going to understand really how plant stems work, you need to understand that. So I'm going to give you some questions. Could you please identify in these pictures where is the high pressure and where's the low pressure, what is about to move and which direction is it about to go in? So for example, I've got a nice bulgy packet of crisps here with lots of gas inside it. So the gas inside is at high pressure, it's not got a lot of space, it's bumping into the bag. The low pressure is outside the bag. So if I squeeze the crisps enough, the air will come out with the crisps. Can you, just very quickly, we won't do this for too long, but can you tell me where's the high and low pressure in a bottle of pop? And if you take the lid off, which direction will the stuff go in? If you prick a balloon, where will the air inside go? If you blow over a toilet roll, and the trickiest one, if you pull up on a syringe and the syringe is in some water, where is the high and low pressure? And what direction will the stuff go in? Sarah says, 22 drops. Well, we know what you've been doing for the last 15 minutes. I'll give you 5 more seconds and then we'll go through it. Oh, nice, yeah, low inside the syringe. Why does the pressure get lower inside the syringe? So the inside, there's pressurised gas inside a bottle of pop, so it's at high pressure. The air outside is at low pressure, so when you take the lid off, exactly, the pop will move to where there is lower pressure, to where there's fewer particles. There's lots and lots and lots of particles inside the balloon, all colliding with the inside of the balloon and pushing on it from the inside. So that's at high pressure, and the low pressure, the normal air with a normal amount of space is outside the balloon. So if you prick it, the air will move from the area of high pressure to low pressure. We talked about the toilet roll, yeah? So when you blow air away. So there's less air above the toilet roll, and there's still more air below the toilet roll. So high pressure below the toilet roll, low pressure above the toilet roll, and the toilet roll will move up. You should totally do that later. And the syringe, Well, what you're doing when you pull up on a syringe is you're making more space inside. You're creating more space, so the air has more space. So that creates an area of low pressure in the top bit of the syringe. And because there's low pressure there, the water that you've covered up with the little hole down here moves into the area of low pressure. All right? Good. What's that got to do? Laura, what's that got to do with stems? I signed up for a biology lesson. This is just more physics. And I like physics, but this is not as advertised. Okay. So, let's have a look inside a stem then, right? You've got a plant, you've got a stem, and you've got roots, and you've got leaves. So, water goes into the roots, as discussed last week. Plants need water. So there's water inside the roots. There's water in the stem. We've talked about that because water's a bit sticky, so it sort of comes up a bit. So there's water in the stem. There's water in the leaves. Why does water travel? Why does water move this way? Why? It's got no reason to move, has it? Oh, flip, Lara. Flippity flip, flip. There. If only we could create some kind of area of low pressure up here. If you could make a low pressure area at the top of the plant, then the water would go that way, wouldn't it? But how does the plant create an area of low pressure? Does anybody actually know this? Adults, you might remember this from GCSE. The force of you pulling the oxygen out of the tube also pulls the water up because you've created a vacuum, suction, or certainly lower pressure. Well, the plant has got holes in it. Oh, plant. You clever thing. There's holes underneath the leaves. They're called stoma, actually, although, again, you don't need to remember that, but some people do like these impressive sounding words. Little holes in the leaves called stoma. Exactly, thank you, Izzy B. Leaves lose water through these little holes. So the water gets to these leaves, and it's, the air is warm and it's windy, and these water particles get carried away. We could say that they evaporate, which leaves more space, so less pressure. So we do have an area of low pressure up here and an area of higher pressure down here, which is why water travels up a stem. Isn't that great? Right. I'm going to give you another question sheet, and then we will kind of finish, although I will do the what I'm calling the incredibly annoying. Julie says, are they smaller than that? Yes, they are very small. Although actually, if you've got a microscope, or if you came to the first lesson and you want to put some water on an adult's mobile phone again, you can put, if you put sellotape on the back of an ivy leaf and pull it off and look at that with a microscope, then you can see them. So I'm going to give you a tough question, and then I'm going to give you loads of clues and help you out. But I want to give you some brain exercise first. So, based on what we have said so far, how much have you remembered? There's been clues throughout this lesson. How is drinking water through a straw similar to water travelling through a plant? And how is it different? So when you drink water through a straw, why is that like what's happening inside a plant? And why is it not like what's happening inside a plant? And can you give me 2 reasons for each? Elliot, thank you, Elliot. Oh, hello. Water moves up the straw because you're creating low pressure when you suck. Like low pressure in the plant created by the leaves losing water. But in the plant, it's not from someone sucking. Wow, dude, that's amazing. That's a very good answer, beautiful. Well done. Okay, after that fabulous answer, I'll put up lots of clues for you. Here we go. So here's some ideas. This is a nice props diagram of what's happening inside a xylem. So the thing that a xylem pulls up is sap, which is water, but it's also minerals, like we looked at last week, like salt. Sap goes up the xylem, but it doesn't fall down the xylem. I've put cohesion, so water particles stick to each other. The cells of the xylem are mainly dead. Is that a similarity or is it a difference? Leaves have holes. Plants, I didn't say this, but plants don't use any energy to transport water. A plant doesn't have to use any energy for the water to come into the roots and all the way up to the flower, which is amazing. And I've put high pressure, low pressure, which is what Elliot's already said to us. Alex, Probably wouldn't talk about vacuums. I would say low pressure. So a vacuum is a place where there is no particles at all, which doesn't really happen here. But you are removing a lot of particles. So it's not a vacuum. There aren't no particles, but you're sucking air away. So there's a lot fewer particles. So low pressure, we'd say. Caris, when you stop sucking the straw, the water goes back down the straw, but in a plant the sap doesn't go back down because the leaves keep losing water. Amazing, well done. Yeah, they actually don't lose, they can, the holes can shut to stop the plant losing water if it's getting very dry. But yes, you're right. All right, let's look at this then. So sap is water and minerals. So that's a difference because hopefully your water was just water. You didn't put any salt in it. Sap goes down up the xylem and not down. Yeah, I think you're right. I think we could say that that's a difference because water can fall down your straw if you stop sucking. Well, there could also be a similarity because if you keep sucking, then the water keeps going up, just like what happens with the leaf. Cohesion, well, they both happen because of cohesion. They both happen because the water is sticking to each other. So I'm going to say that's a similarity. Cells of the xylem are mainly dead. Well, if you were using a bit of paper or plastic or metal, then those cells would be dead as well, or certainly not alive. So we will say that's a similarity. High pressure, low pressure. Lots of people mentioning that's a similarity. Well done. A leaf has holes, and your mouth is a hole. So I guess we could say that was a similarity. Plant uses no energy to transport water, so that is a big difference. We have to eat food in order to be able to do things like walk and run and suck water up straws. Different. Should have put a D. Humans use energy, don't they? And well done if you've said that another difference is that we suck the water, but the plant leaves evaporate the water. Very good. Right, you lot. Quick ad break. My name is Lara. This is my science communication business, theatre of science. Started doing shows during lockdown and they're still going. So you're at the home ed one, but at the weekend, as you mainly know, there is a science show where we do like Lego story time and there's an activity with household objects and we dig into a certain topic. So we did nest building last weekend and sharks before that, and it's deserts this weekend. If you're enjoying everything I do, then how you can help me out is you could like my Facebook page, or you could subscribe to me on YouTube, or you could look me up on Instagram or Twitter, or you could share this and tell your friends about this. Or, grown-ups only, children just relax, you could sign up to Theatre of Science magazine. So if you go to my Facebook homepage and you click sign up, it takes you to this website called Patron. It's thanks to my amazing patrons that I am still going. It started off as a very fun hobby to do during lockdown, but now it's my job. So anyone who's supporting me monetarily gets various thank yous to say thank you for being so wonderful. So if you sign up with £3 a month, then I send you these rainbow glasses that make you see rainbows. And I'll explain to you how they work. And if you sign up with £5 a month, you receive Theatre of Science magazine. So this is January's, which was on snow, but I'll send you this if you sign up now. Matthew, if you look up Theatre of Science on YouTube, then you'll get to it. Thank you, Sarah, for doing that. So yeah, the snow, hopefully it's just a magazine version of the shows. So Snow had like a little snowflake spotting guide and how to fossilise a snowflake, a little comic strip about Shackleton's adventures and the science of does Bigfoot exist, and I'll send you 2 free biodegradable plastic bags. So you can do that making ice cream with salt activity that everyone's always banging on about. Hunter's eating the celery. Yes, Hunter, well done. So thank you ever so much to everyone who signed up to the magazine. I'm writing Issa's at the moment. I'll be with you fairly soon actually on chocolate. Okay, let's do this celery activity. Have you got... I totally failed to get celery, but I do have some lettuce. So what you do is, this is another like classic YouTube name, Matthew, it's just Theatre of Science. Everything I do is Theatre of Science. This is another classic online activity. Instagram makes it look really good. Mine that I did yesterday is looking rubbish, but I'm going to try again. Basically what you do is you put a leafy plant in food colouring, and you should be able to see, after a few hours or days, water, you should be able to see the xylem, because the water travels up the xylem, so the xylem get dyed, right? So I did the whole lettuce yesterday, and it didn't work, so this time I'm just going to use a lettuce leaf. The classic thing to do it with is celery, or I did it with some cauliflower leaf the other day. That's looking quite good, actually. Look, can you see? Can you just start to see where the blue dye has actually hit the leaves? And if you can see that. So that's quite interesting because we're doing leaves next week. So you get to see the xylem, but also you get to see where the xylem delivers the stuff to. So yeah, you could just get a leaf, put some water in a cup, put as much food colouring as you can in, and then put the leaf in the cup. I'm going to do the slightly more exciting thing that they do on Instagram, which is where you split the leaf in half. If you've got a stick of celery, don't split it all the way, but just kind of cut it half the way up so it looks like it's got legs like that. And then you could get 2 cups if you want. If you've only got 1 colour food colouring, just do it with 1. But I've got 2. And purple is my 2-year-old's favourite colour. So I'm going to put some blue food colouring into this cup and some red food colouring into this cup. Oh, I know, Alistair Griffin, you've started eating green things. Dude, I'm so proud of you. I'm so proud of you. We're at that age, aren't we? Are you a bit old? I feel like you're a bit older than me. If you hit 40. And started eating green things. Well, I look forward to that stage in my life. Hello, Lara. What do we do with celery? Martin, this is all happening live right now. So you get your piece of celery and you cut it about halfway along so it looks like it's got legs, right? Like that. If you've got 2 colours of food colouring. And then what you do is you put the cups together and with no expectations whatsoever, because mine hasn't worked. I think it works well with celery. You just make the little leaf straddle the cups like that and wait and see what happens. Shall I show you what happened to mine yesterday? So I did this lesson yesterday and people are now sending me beautiful photos of what their celery looks like, and mine looks like this. Not good. I'm wondering if it's that this bit at the bottom is too big. Yeah, I bet you do, Alistair. Well, you know, you're a lockdown hero, mate. It's tiring. Yeah, there we go. So I'm just doing 1 leaf this time to see if that works. I'm going to put that on my special shelf of vegetables that are slowly dying shelf. Let's move that up here. Can I hold 2 cups of food colouring and a phone? What could possibly go wrong? There we are. So next week we'll come back to this shelf of death and we'll see what's happened. Oh, I just can't wait. There we go. Right, I'm so sorry. It's time for the GCSE question, isn't it? You've been ever so patient. Right, you are going to smash this GCSE question, you lot. I really, truly believe that. What you're going to do is you're going to hugely overthink it and write too much. Take it very easy. Just make it as simple as you possibly can. Okay? GCSE question, 2 marks. Stomata, it sounds really scary, but it's not. Stomata are holes found mainly underneath leaves. Explain the role of stomata in transport in plants. What that actually means is leaves have holes in them. Explain why that helps water to get transported up a stem, all right? Why does stomata help water move through a plant? So this is so horrible because you can imagine people sat in an exam hall in silence and the clock's ticking and you read all those horrible words and you just go, oh no, I can't do it. It's so simple. Like, you don't even talk about high and low pressure. Just make it as absolutely simple as you can. Pretend that you're talking to a 4-year-old. Why does having holes in leaves mean water travels up a plant? Is celery xylem the strings? Thank you, Lauren. Yes, exactly. Exactly. Well, it's a bundle, actually. So there are more tubes in there, and we will look at those ones week after next when we do respiration. Do you want the answer? Do you want the answer? You'll be so annoyed if you wrote more than 2 sentences. Oh, Carrie stage 9. All right, let's hear your good. The holes in the leaves mean some water can escape, which creates low pressure at the top. So the water travels up the stems of the leaves. Carrie stage 9. I think you've actually got 4 marks of GCSE there. Look at this. All you say is they allow, so they've used words like evaporate or diffuse, but you got a mark for just saying they allow the plant to lose water. So if you've said that water leaves the leaf through the holes, you get a mark. And if you said that pulls the water up, you get a mark. Lenny, age 4, asks, Lenny, what a brilliant question. Why do plants need water? Oh my goodness, that is such a good question, Lenny, that I think a lot of people never ask. We just take it for granted. We're going to do this next week. We're going to look at how plants make their food next week. And I'll tell you all about it. They actually really only need the hydrogen that is in the water. It's very interesting. Water is hydrogen and oxygen. Well, they need water for lots of things, but to make their food, they split water particles. So some of it, the oxygen just gets chucked away, luckily for us, and it's the hydrogen that they use. It's amazing. I'll tell you next week, Lenny. Okay, folks, that is definitely now the end of your lesson on stems. Thank you so much for joining me. Incredibly patient, resilient people. Resilient means you don't mind going wrong. Yes, Matthew congratulating Lenny on his excellent question. Okay, so I'm going to do this. I think we're getting lots of good questions now. Thank you, Kim. Yeah, exactly. So, well done, everyone. Thank you so much for coming. I'll see you at the weekend for the deserts show, or next week for leaves, photosynthesis, how do plants make food? Like, really? How? Particles? Oh, love it. But for now, I'll say cheerio, bye-bye. Thank you so much for coming, and I'm going to do some shout-outs and answer questions. Or maybe just learn something. I'll see you afterwards. When you chop a tree